We are going to hear from Dr. Alan Russell, who is the head director of the Disruptive Health Technologies Institute of Carnegie Mellon University. And I'm hoping, oh, there he is, okay. So here is Dr. Alan Russell.
Thank you very much, Simon, and I'm delighted to be here and to talk a little bit about some of the work that we've been doing at CMU and some thoughts on how to use disruptive technologies to change the future of healthcare, which is really an ongoing theme, I think, from all of the people we've heard from this morning. So let me just begin by saying that I'm going to try and make some general remarks, some general thoughts about innovation in healthcare by focusing on some particular problems. And the one I picked for today is the problem of chronic non-communicable diseases that have perhaps a particular relevance in the Middle East, but also beyond. And this little chart up here is kind of busy. You don't need to worry about the details. The point is that if you look at all of the big chronic diseases that cause us challenges today, medicine has done a really good job, and society's done a really good job with all of them, except for one, and that's diabetes and obesity, which is just getting worse and worse. So I thought I'd sort of make my remarks by tackling those two, and just to give you a sense of how poorly we do, not just as a region, for instance, in the Middle East, but worldwide, when it comes to obesity and diabetes. I just want to sober us with the real facts. So, and no, these are not alternative facts. So 500 million people around the world are obese. 40 million of them are children. And obviously that contributes hugely to disease. All sorts of different health outcomes are challenged by these realities. Perhaps the most devastating one is diabetes. 500 million people with diabetes worldwide. Half of them are undiagnosed. They don't even know they have diabetes. And since I started talking, somewhere around 50 to 100 people died as a result of diabetes around the world. The global prevalence of diabetes has doubled in the last 4 years. And there's a statistic up there by the image of the word sugar drawn in cocaine powder that's interesting. If you take rats that are addicted to cocaine and you give them a choice as to what they'd prefer to take, cocaine or sugar, 40 of 43 rats will choose the sugar. So really a very powerful disease with very important consequences. So if you look at those numbers, it's pretty clear that health innovation, at least in respect to obesity and diabetes, has a big F worldwide associated with it. Lots of advances, lots of tremendous advances, but they're not actually cracking the nut just yet. So one of the things that we've been doing at Carnegie Mellon University for the last 5 years, we started this Disruptive Health Technology Institute, and the vision really was to try to identify the right technologies that would drive the right care to the right patient at the right time, place, and cost. It sounds very easy, it sounds very simple, but as you heard from Derek Angus, when you have 1 million research papers a year, sort of doubling, he said, every decade or so the amount of knowledge, it actually means that a clinician that graduates medical school, approximately 75% of what they've learned could be out of date by the time they graduate medical school from when they started. So real huge impact. How do you actually find your way through this morass of ideas and technologies to find the things that actually work? And one of the biggest challenges in healthcare is that innovation and the people doing innovation tend to build their silos, and the silos don't easily connect one to another. So one of the themes that I'm going to talk about today is sort of built around this work of Nassim Taleb, which I think if you haven't read about anti-fragility, it's a wonderful thing to think about, and with particular impact on healthcare. So Nassim's main suggestion, his central thesis, is that fragile systems break under pressure. And what you really want in innovation, particularly in healthcare, are innovative ideas that strengthen under pressure. Not that just maintain themselves under pressure, but actually get stronger. Why? Because the healthcare system is not even healthy, nor is it caring, and nor is it a system, right? It's a very fragmented process. Any of us who've had loved ones who become seriously ill quickly find out how difficult it is to find your way to the right care and the right set of solutions, even in places with unbelievably outstanding care, like what you just heard about at UPMC. It's still difficult sometimes. So anti-fragility is this idea that one needs to try to find ways that unite ideas so that when the stress begins, the response, the innovative process, the innovative idea actually becomes stronger. The key, I think, is this sequence of words that I put up there: listen, coordinate, small steps, review, and implement. It's so important when you're looking at new healthcare innovations, new ideas, that you're able to listen to what's going on, coordinate the activities of that group with existing care paradigms, and this is maybe one of the things that is the hardest thing to do, and then after that coordination, have multiple ideas that are all targeted towards a single clinical goal, take small steps in multiple different directions, talk again, and then find the right path, the right way forward, so that you can quickly fail. It's a little bit like if you break a bone and you're healing your bone. If you don't put pressure on the bone, it becomes weaker. So anti-fragility, this idea that pressure and stress can actually strengthen something, is truly a health theme anyway. So I think that the key, not just in obesity and diabetes, but actually in many health innovation areas, is to build this kind of health innovation, anti-fragile health innovation process. So how does science, how does innovation battle fat and sugar? I'm going to tell you about a few short stories, and you heard a couple of our speakers talk about their conflicts of interest. I have far too many conflicts of interest to mention, but I'll just mention no conflict, no interest. So I'll try to mention them as they go along, as I go along here. I thought it might be interesting, and I'm just using these short stories as examples of things that I think are particularly innovative. In some cases, it's things that we're working with. In other cases, it's not. But the key is to actually create a cycle, to create a discussion between all these new and existing emerging technologies so that you do take these small steps in a coordinated way in order to make change. So I'm going to begin with perhaps the most obvious, perhaps maybe some people would say the most exciting, and that's this whole concept of personalized medicine, personalized healthcare. And in this sort of shifting of hype to hope, I'm going to focus in on one aspect of personalized healthcare, and this is this whole idea that we can use the genome of each of us as an individual to guide care, to talk about one of the realities for patients with diabetes. So once diabetes has taken a hold, an average patient with diabetes will have about 11 drugs that they're taking at the same time. But 3/4 of those drugs will be metabolized in a genetically controlled way. So their individual genome will decide for them how they respond to those drugs. So it's a little bit like if you were to ignore this fact, it would be a little bit like saying, I want to get from A to B, but I'm going to just guess how I'm going to get there, even though there's a roadmap available. What does it actually mean? It means that 50%, half of those 500 million people, so 250 million people around the world, have moderate to severe drug-drug and drug-gene interactions that would be known if we simply knew their own personalized genetic information. So the first thing that I'm going to talk about today is how you can get around, or a method for getting around this blind spot that currently exists. And this is really simply a technological challenge. It's how do you afford to test the people, and how do you take that information, that wealth of information? You just heard the extraordinary data information challenge that exists when you have petabytes of data. How do you actually get that information into the hands of a physician, not so that it just educates them, but so that they actually change care? And that's difficult. So this, the next company is a company, if we can just advance the slide by hand. Thank you. And just give it one more click. This is a concept, again, just building off that roadmap analogy, the idea that you can deliver the right drug at the right dose right now. And if you give it one more click, it's really just like Google Maps that takes genetic information, the drug information for our patient that may be on, as I said, on average 11 medications, but up to 30 different medications can be being taken by a diabetes patient. How do you take that information and then just give the map to a clinician so that they know exactly what they would like to do? The company that I'll talk about that has a solution, and it's just one of many companies, is called UScript. They have, I think, a beautiful way where they can first take a population, identify using big data analysis and algorithms who in that population should get a genetic test, who's at risk of a drug-drug or drug-gene interaction that is genetically controlled and therefore solvable if you just had the information. Then they test, and then they report back in this rather nice personalized treatment plan so that they can actually change care. And in some of the clinical trials that have been done using this tool, using other tools, you see really dramatic advances that could be made. And this really is an area where you can develop anti-fragile innovation. However, I believe that it will really only work effectively, if you want to advance that slide by hand, again, if you connect it to other emerging technologies that can also be important. And for chronic diseases, this cycle of personalized medicine, neuroscience and behavioral science, improving the behavior of patients, the Nobel Prize just got awarded today for behavioral economics, clinical enablement, you heard about that, how do you make doctors more effective and healthcare workers more effective, and focusing on children. If you can bring technologies that bring all of those things together and deploy them at the same time, I think we can make a difference. So the one I'll just talk about briefly when it comes to neuroscience and behavioral change, although there's tons of work, beautiful work being done by multi-billion-dollar companies, I'm going to pick on a tiny little company which I don't have any relationship to, but I just love the work that they're doing. And just to set it up, just to give you a sense of where we are, most diabetic patients don't take the medications properly that they've been prescribed. That they know that the disease will kill them, but their willpower doesn't overcome the desire to take the medications. So that's really the core of the problem. I talked before, 250 million people around the world, okay, don't have the right genetics and don't know it, but could. 200 million people around the world know exactly what's wrong, but don't do anything about it. So that's a significant opportunity. Well, it turns out there's a ton of behavioral science and economics around this issue, and it sounds kind of fluffy, but the reality is that if you feel good about yourself, you have a much greater ability to make good decisions for yourself, especially for your own health. There's a famous study that I particularly like. It's a fairly recent study that was published on what people do after their sports team that they support passionately loses. And the reality is, as many of you may have experienced last night, they eat, and they eat bad stuff. right? And so they load up on carbs, they load up on alcohol, et cetera, when their team loses. Well, it turns out that in this experiment, if you, before the game, remind them of their self-worth, of their values, and there are many ways to do this, they actually eat less bad stuff, even when their team loses. So simply by giving people a reminder of their purpose in life, reconnecting them to their purpose in life, they make better decisions. So this, the most famous researcher in this area is in Michigan, Victor Strescher, a professor there, and he's the person that has really demonstrated, this is a paper from the Proceedings of the National Academy of Science, where they showed that purpose in life has a direct effect on healthcare outcomes, particularly, by the way, for diabetes patients. So they spun out a company, it's called Jewel Health, this is the app, and the only app really does, it's very clever, gives feedback to doctors and payers and patients. It's more addictive, it's in the top 10 of most addictive apps, so the people that have it interact with it more frequently than they interact with Facebook, than those people that interact with Facebook, which is great, so it's highly addictive as an app, but the app reminds people what their purpose is, and they make better decisions as a result. So an exciting new technology. I'm going to zip through the last few fairly quickly. This is just the app user data. Clinical enablement, I think you heard a lot from people far smarter than I am about how doctors can be enabled to make better decisions. And there's a lot of discussion ongoing about these kinds of things. I'll just make 2 points. The first is that we continue to build hospitals that look like hospitals and do what hospitals do. I'm personally convinced that the right kind of hospitals to build as we enter this next decade or 2 decades are hospitals that actually take all of the data that's being generated, whether it's by YouScript or Jewel Health or Fitbit or more serious clinical processes, but take those in and really act like an air traffic control center, where doctors and nurses and people that can intervene are scanning the data with the aid of computer-based algorithms from tens of thousands of patients, finding the ones that they actually need to talk to each day, so that they can stop the process of waiting for a patient to come to them and actually intervene. So Mercy Health System in St. Louis is just a particularly beautiful way. That building that I showed before is their hospital of the future, which has no patients inside, just has their data. I also think that today we wear data-absorbing devices like Fitbits, Apple Watches, whatever. One of the exciting things that we're doing at CMU, Carmel Majidi and Adam Feinberg are developing soft electronics, and those soft electronics are being turned into wearable clothing that can measure clinically relevant things. For instance, blood pressure, or all of these kinds of things. And the idea here is you get away from the idea of putting something on your body to measure a health statistic, and instead you go to clothing that's just smart and wearable. And one of the big challenges there is just the material challenge of how do you make a nice, flexible, washable electronic material. And then lastly, I think it's critical to focus on children. The reality is that for chronic diseases, whether it's diabetes, obesity, and many others, and I don't say this to be depressing, but it's just a reality, that maybe we lost a generation. We didn't respond quickly enough for that generation. That is not an excuse to lose the next generation. And we really must focus on children. It's in many cases a reality that parents love their children more than they love themselves. Those of us with children, I think, have a natural understanding of that reality. So developing technologies and finding ways to test technologies that are perfected for children, critically important. Those of you that don't know, Carnegie Mellon has an entertainment technology center, probably the best in the world at this business, and they are spending a great deal of time not just thinking about what's the next best game for an Xbox, but actually thinking about how can you use the technology inside entertainment technology to drive health and to do it directly for children. I'll give you one example of some beautiful work that's being done to develop asthma inhaler education system. So they take the Kinect box, the camera, on an entertainment system. It watches a child shaking their inhaler, taking their inhaler. Approximately 95% of people that use inhalers use them incorrectly. So it watches them do that, and it intervenes while they're doing it. So it says you didn't shake it 3 times, you only shook it once. You must do this. So it's already being tested clinically now. A beautiful example, I think, of how technology can be used to work and focus with children. So let me just finish up with a thought. Many of us, everyone on the last panel, have been in this game for a while. And we always talk about the future with great confidence and tremendous thing. And then there's always someone crusty in the audience who's thinking to themselves, or even asks a question as, well, when will this really actually happen? Or will this ever really happen? And I think one of the most fascinating things to me is how quickly, when it happens, it really does. I think someone mentioned this morning the iPod and the iPhone. When technology actually wins, when it's done in the right way, it can actually create great change very quickly. And although the healthcare industry and health has been highly resistant, almost as resistant as education, to innovation, this really is an exciting time because I really believe that this is going to happen very quickly. So the picture here is just an example of what happens when when things change, what happens to the status quo. Because the status quo is we don't deliver the right care to the right patient at the right time, place, and cost. We yearn to, but it doesn't happen. So what's going to happen with that status quo? This is a picture of the Choluteca Bridge. It's in Honduras, and it was built in the 1970s to withstand hurricanes. Because Honduras got a lot of hurricanes, all the bridges would get knocked out. It was very devastating. This was an important highway. So with a lot of aid money, they built this amazing bridge. Right? And what happened when Hurricane Mitch came along, Category 5 hurricane, to this bridge, I think is emblematic of what will happen and what happens to the status quo when it's challenged by the storm of innovation. And you're probably thinking yourselves, he's about to put up a picture of the bridge in ruins. But that isn't the way that innovation works, and it's not the way that the bridge responded to a challenge. What happened is that the river moved and the bridge became just a little less relevant, right? The bridge stood, right? And this, I think, really is the case. We're not going to see, hospitals go away. Our care is not going to be delivered purely virtually with the aid of amazing devices. Our care is still going to be driven by incredible clinicians who do what they do. But the status quo is going to be less relevant. And the river will move, and I believe it's really going to move to a place where we will be able to deliver the right care at the right time, place, and cost. Thank you very much.